Hello everyone, I'm Mohammad Hassan, currently pursuing my UG at the Savita Engineering College in the Department of AIML. So I'm here to explain you and walk you through this source code, which is meant for implementation of MLP for a non-linearly separable data. Let's get into it. So I'll be explaining it to you in four steps or four methods, which are objective of the experiment, program implementation, execution and result, and also the applications of the MLP. So let's dive into the objectives first. So our objective is to build a neural network using MLP, that is multi-layer perceptron model, to solve XOR problem, which cannot be solved using a single perceptron because it is only capable of binary classification. The MLP will learn to map inputs to the expected outputs using forward and backward propagations. In this forward propagation, the activation function and also the summation of the product of the weights and inputs are calculated, and also they are turned into the activation function using a sigmoid function. So in the backward propagation, we actually find out the local gradient and also the error propagation and update it in the weights for a better optimized model and a lower error. So let's dive into the code. So first we are importing the necessary libraries such as pandas and numpy. Pandas for data manipulation and data frames, whereas numpy is for working with arrays and etc. So also we import matplot library, which is used for to plot graphs and see the data visualization of the algorithm. So x and y are x are inputs and y is the output, and we turn them into arrays. And here W1 and W2 are set randomly. That is, W1 and W2 stands for the weights for the hidden layers. W1 stands for the hidden layer 1 and W2 stands for the hidden layer 2. And this defines the sigmoid function Z, and we are able to calculate it, which stands for 1 by 1 plus e power minus Z. And here the forward propagation, as I said before, forward propagation calculates the summation of product of the weights and inputs in a single layer and also converts them into the activation function, that is here the sigmoid function. The backward function, as I said before, it will calculate the error propagation and also the local gradient based on the current layer's input. So here the number of iterations is set to be 10,000. So that many times, like 10,000 times, we have to run this for loop to get the optimal solution. So after the 10,000 outputs, that is iteration, we get to the last part, that is displaying the details, that is plotting the graph and showing the differences. So as you can see, this is the input and output. So basically what the XOR function does is, if you give like inputs, the output is 0 or known as false. But when you give it as unlike inputs, that is 1 or 0 or 0 or 1, you will get it the output as 1 or true. So this is the error graph, which tends to be starting at a high value, but slowly curves up and ends up in a lower value. So our model tends to be effective. So yeah, that will be for the code and the explanation of the model. So lastly, getting into the application of MLP. So applications of MLP include that this can be used for pattern recognition, regression, that is predicting a real value, and also for medical diagnosis and control systems in the field of healthcare. So thank you for watching. Hope it was helpful.